For this, we need to determine the domain, and because we have a fraction with a variable in the denominator, we will have a restriction on the domain here. So x minus 3 equaling 0, we find x equals 3. So for the domain, it's all real numbers. But x cannot equal 3. And right here, 3 would be right here. If we drew this vertical line at x equals 3, you'll find out that this graph comes close to it, but does not cross it. Here's one more. We want to determine the domain, and for this case, we're also going to find the range. So looking at the domain, we'll find that x, 9 minus x, is under the square root symbol, so that has to be greater than or equal to 0. So negative x is greater than or equal to negative 9. You remember when we change the signs, we have to change all the signs, including the inequality. So x has to be less than or equal to 9 for the domain. And you can see that on the graph. The x values, here's 9, and x is less than or equal to 9. For the range, in this case, we can look at the graph, and we want the bottom up. So from the bottom up, the first place we come to is 0. So x is greater than or equal to 0 because it does get larger. So that would be the range. We need to determine whether or not it's a function, explain your reasoning, and find the domain and the range. So this is the amount of U.S. sales of personal computers in millions of dollars determined by the year X, as defined in the table. Are the sales, the N here, a function of the X? Well, let's look at the X. For each X value, there's only one given Y value. So we would say, in this case, yes, N is a function of X. The domain would be the list of years, 1997, 2000, 2004, 2008, 2009, and 2010. In this case, we would just list the numbers in the domain, and the range would be then these values. It'd be 15,950, etc. These values would be the range, but we would have to do one more thing and say, of course, this was in millions of dollars. So after this, we would really add 6 more zeros, and this would be 15,950 or 15,950,000,000. Okay, those would be our range values. Here we need to determine, is y a function of x? That means for each x, there's only one y. I want to show you something with this first one. Let's say x was equal to 2. So it would have 4 times 2 minus 4. Y squared equals that. Y squared equals 8 minus 4, or 4. So y would be the square root of 4, or 2. However, 2 times 2 will be 4, but also negative 2 times 2. So this would be plus or minus 2. So we found out for this 1x, there are two different y's. So does it define a function? No. Now for this one, when we picked a x value, this would say if x equaled 2, it would be negative 2 squared, or 4, plus 6 times 2, 12, and y would equal 8. We only get one value. This would be a yes. And for a general rule, if a y equals, it's a singular y, something with an x squared, that's going to be a yes. But if your function has an even power of y, that's going to be a no, because you could have the plus or minus values. So if it's a y squared or y to the fourth, it's probably going to be a no. There's what we call the vertical line test. A set of points in a coordinate plane. So if you have a graph, is the graph of a function if and only if no vertical line intersects the graph at more than one point. Well, let's look at some examples to see what we mean. Okay, this one is a function. We see the vertical line only goes through it once. And even if we kept drawing a variety of vertical lines, it would still only go through it once. For this one, it's not a function. This vertical line, or this one, there are several that would cross it twice. So this would not be a function. That's the vertical line test. Works great if you have a graph. We have a figure here. We have a graph of the function f of x equals 2x cubed plus 5x squared minus 28x minus 15. We want to find f of negative 2 and f of 4. That means we want to find out what this function equals when I put negative 2 in place of the x. Well, since we have the graph here, it's the easy way to do it. This point, we know, is negative 2, 45. So we talk about ordered pairs, f of y, f x y, that also is the same as x, the ordered pair x, and f of x. So since we would have negative 2, 4, so f of negative 2 from the graph is 45. And from the graph, f of 4, since we have the ordered pair 4, 81, f of 4 would be 81. So remember those values. And now we want to use the equation to find it. So using the equation, f of negative 2, we would put 2 times negative 2 cubed plus 5 times negative 2 squared minus 28 times negative 2 minus 15. Well, remember we do powers before we multiply, so this will be 2 times negative 8 plus 5 times 4 minus 28 times the negative 2 minus 15. Be negative 16 plus 20 plus 56 minus 15. Well, these two adding together would give you 4. These two would give you 41. Adding them together, we get 45. Same answer we had from the graph.